Welcome to Homework Lib.
Here we have a pipe which has the following resonant frequencies: 60 Hz, 100 Hz, and 140 Hz. And we want to know if it is an open system or a closed pipe. First of all, let's notice that the values for pressure on the open system correspond in black would be the wavelength for the fundamental, and in red we're going to have the wavelength for the first harmonic for n equals 2. And we see that the wavelength for the fundamental is going to be equal to 2 times L. Thus, the frequency is going to be equal, in the case of the fundamental, is going to be equal to the velocity of sound divided by the wavelength of the fundamental frequency. And this is going to be Bs over 2L. If we want to get the value for the second harmonic, we're going to find that the wavelength is actually, for lambda 2, this is going to be equal to L. So this becomes Bs divided by L. In general, for Fn, the value for the frequency is going to be equal to n times Bs divided by 2L, where Bs is the velocity of sound. On the other hand, when we have the closed system, the fundamental frequency is going to correspond to a value of 4L in the wavelength. But the interesting part about the closed system is that since we have the value restricted at the maximum value for pressure, the next harmonic corresponds to the following situation, where we're going to have still one note, like somewhere in between, and then we're going to get over here. But guess what? Due to this restriction, we're not going to have a second harmonic. We're going to be directly to the third harmonic. This happens because this lambda is going to be equal to 4/3 of L. So lambda corresponds to a value of 3 because we're going to have lambda 1 divided by n. Thus, the frequency for the closed system is going to be only for odd numbers. So f1 is going to be equal to the velocity of sound divided by the fundamental frequency, that is 4L, multiplied by n. Sorry, the frequency for the nth harmonic. But the restriction is that n is odd. So the possibilities that we're going to have are f1, f3, f5, and so on and so forth. With this information, we can identify which type of system do we have. For example, in the open system, if we do f n plus 1 minus f of n, what we get is n plus 1 times my fundamental frequency minus n times my fundamental frequency. This is going to be equal directly to my fundamental frequency. So the difference in between consecutive harmonics for an open system is going to be the fundamental. So, for example, in this case, let's say that this is that 60 Hz represents the fundamental, then the next harmonic would have to be 100 Hz, 140 Hz, and so on. In this case, this cannot be an open system because even though we have a difference in between each of the harmonics of 40 Hz, for this to be true, the fundamental frequency would need to be equal to 40 Hz. And there's no way of going from 40 Hz to 60 Hz in an open system on the harmonics. The second one would correspond to 80 Hz. So we can discard an open system already, and probably the result is going to be that we're going to have an out system. So what we are going to do is get the same result, but now we're going to put f of n plus 2 minus f of n, and we know that these values need to be odd numbers, right? So f of n plus 2 would be n plus 2 times the fundamental frequency minus n times the fundamental frequency. This is going to be equal to a difference of 2 times the fundamental in between each other. So now if we compare the values that were given, we have 60 hertz, 100 hertz, and 140 hertz. We said that the change of frequency was equal to 40 hertz, right? Thus, the fundamental frequency for this system would be equal to 20 hertz. And the difference in between 20 hertz and 60 hertz is equal to 2 times that value. So the system that we have in this case is going to be a closed system. And the frequencies correspond to F2, F3, and F4. So with that, it would be all. Thank you very much and have a good one.